Good morning, third grade. So today we are continuing with measuring and estimating volume, but before I do that, I wanted to look at a quick problem of the day. I know that there were fractions and comparing fractions in your spiral review from your homework yesterday. So I just wanted to make sure that we are remembering that material, right? What you do when you see a number line and you have to put it on, or put your fraction on the number line. So as you can see here, we have 6/4. Now remember, when we discussed fractions a few months ago, you know that when the numerator is larger than the denominator, we are working with a fraction that is greater than 1 whole. The denominator here is fourths or quarters, okay? There's 4 equal parts, but we have 6 parts out of 4, okay? That means that there are more parts than that are in our whole. So that's why I have on my number line here 0, 1, and 2, because I have more than 1 whole. Because my denominator is in fourths, I'm going to make sure that my first whole is partitioned into 4 equal parts. Remember, my denominator tells the number of equal parts for 1 whole. So from 0 to 1, I'm going to mark my 4 equal parts. 1, 2, 3, 4, okay? From 1 to 2, my next whole, I'm going to put my 4 equal parts. 1, 2, 3, 4. Now I'm going to go ahead and start labeling with my fractions. So I have 0 or 0/4. We have 1/4, 2/4, 3/4, 1 whole or 4/4. Okay, so 4/4 is a whole. We're going to continue on. 5/4, 6/4, 7/4, and then 8/4 or 2 wholes, right? Because 4 and 4 makes 8, so that's 2 wholes. So where is 6/4 on my number line? It is right here. That is where 6/4 is located on my number line. So if this is 1 whole, we know that 6/4 is 1 whole plus 2 additional pieces, okay? So you can say that it's 1 and 1/2, okay? Those would be equivalent to each other. So moving on, today is the same objective as yesterday. Today we'll measure and estimate liquid volume using standard units of milliliters and liters. So if we remember, we know that volume is the amount of space within a three-dimensional object. So we're not thinking about the outside of an object, but we're talking about the inside, the amount of space inside that 3D object. Okay, so if you had a water bottle, how much space is on the inside of your water bottle? We also know that 1 liter is equivalent to 1,000 milliliters. So I told you that 1 liter yesterday. I gave you a bunch of different examples in my big gray Nalgene that I always carry at school. That's about 1 liter. So 1,000 milliliters equal 1 liter. So 1 milliliter is a very, very small amount. Okay, it said yesterday that 1 milliliter is about the size of an eyedropper. Okay, so if you think about a little eyedropper, one of those is a very small amount. You need 1,000 of those in order to fill up my entire water bottle with liquid. Okay? We also want to remember that when we think of milliliters and liters, we're thinking about liquid. Okay, so when you're finding the volume of something in liters and milliliters, we're talking about how much liquid is inside of that, how much water is inside of it, how much chocolate milk's inside of it, how much Shirley Temple is inside of it. Okay? So let's go ahead and get started. For the teacher input, we are going to measure the liquid volume in the beaker, okay? So you can see here that we are not estimating. We're actually finding an accurate measurement. I know this because I have ticks, okay? In my volume line, my liquid line that I'm trying to figure out what the volume is, it's on a tick. So I'm going to find an accurate amount, an accurate amount of milliliters. So if this is 100 right here, I can see, kind of like a fraction, that all my intervals are equal. So that tells me that I am most certainly counting by hundreds. So 100, 200, 300, 400, 500, I know I'm correct, 600, 700, 800, 900, and 1,000 milliliters, or 1 liter, okay? So you can see that my line right here is, my volume is 600 milliliters. Now I want you to think about how much 600 milliliters is. So if you know that 1,000 milliliters, okay, is equal to 1 liter, and you know that 1 liter is that size of my Nalgene bottle that I bring to school every day that has my straw, okay, my big gray Nalgene bottle. 600 milliliters is a little bit more than halfway filled up of that water bottle, okay? So we're a little bit more than halfway to having 1 liter of liquid, all right? Now let's go ahead down to number 2. This time we're estimating in milliliters. Why are we estimating? Well, we don't have those tick marks there. We don't have those little intervals like we did before, so we have to make the most accurate guess based on what we know. And if I look at this, I'm gonna think, this line right here looks like it's right about in the center between 500 and 1,000. So I'm thinking, okay, if this is the center of 100 and 500, what's about halfway, okay? Or if something even easier that you might wanna do is mark your count by hundreds and make sure that each of your intervals are the same. So 100, 200, 300, 400, there's 500, okay, 500, 600, 700, 800, 900, 1,000. So 200, 300, 400, 500, 600, 700, 800, 900, and 1,000, or 1 liter. Okay, so we're making an estimate, and I can see that my dash right here, my solid line, where my amount of liquid goes up to, is right between 700 and 800. So I can probably make a pretty good estimate that the volume is about, or this is our about symbol, 750 milliliters. Okay, it's about 750 milliliters. So that's closer to 1,000 milliliters than my last problem was, okay? So that is estimating. So let's go on together to the structure guided practice. If you need to pause this right now, go ahead and do so, and then join us. So measure the liquid volume in the beaker. These again are the ones that we like. It gives us intervals, and that makes it really easy for us to have an accurate volume here, an accurate amount of milliliters. So we see that our interval starts at 10. Our intervals must be by tens. Why? Well, because from here to here and from here to here and all the way up, just like fractions, they're equal to one another. So if I have 10 milliliters here, I have 20, 30, 40, 50, 60, 70, 80, 90, and 100 milliliters. So where is my volume line? Well, that's even simpler because it tells me, doesn't it? I'm right at 50 milliliters. Okay, now think about 50 milliliters. The last beakers that we worked with the top was up to 1,000 milliliters. We're only going up to 100 milliliters. 1,000 milliliters is 1 liter. So 50 milliliters is barely any liquid, right? So if I had my big water bottle, and my water bottle is 1,000 milliliters all the way to the top, or 1 liter, and I only filled it 50 milliliters, well, here's halfway, 500. 50 milliliters would barely be anything. That would be silly, right? If I said, oh, can you go fill my water bottle up, and you came back and you only filled it up 50 milliliters, and I got just 1 little drip of water, I'd be like, holy moly, friends. What are you doing? I want 1,000 milliliters, not 50 milliliters of water. So remember, 50 milliliters is a very, very tiny amount when you can visualize in your head that 1,000 milliliters is 1 whole liter, okay? And then last one, estimate the liquid volume of the beaker. So how can we do this? Well, I know that my halfway, so it's 100 milliliters to 1,000. This is a little bit less than halfway, I would say, but it's pretty close. Okay. So we know that right in between is, well, and you have to also remember that we're starting at 0 as well. So we want to look from here to here, 0 to 1,000. So you could probably say this is in the middle. So what comes right in between 0 and 1,000? Well, we know that that's 500 milliliters. So you can say that my volume here is about 500 milliliters, about 500 milliliters, okay? So you want to use your knowledge, your number sense on these estimation problems by either counting in intervals. Here you can count by hundreds, but you have to make sure that it makes sense. 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000, all right? Or you can draw your halfway mark and use that as a way to estimate, all right? So, for your final check, once again, you're gonna be measuring and then estimating in milliliters. The one that I did want you to pay attention to here, it wants you to explain your thinking. So when you come up with an estimate of the liquid volume in the beaker, I want you to write how you know that. How did you decide how many milliliters that was about? How did you come up with that? What was your strategy to solve this? Did you count by intervals? Did you show a halfway point in between all of these? And remember, you want to look at it as if this were 0, okay? What did you do? How did you solve? How do you know, okay? So that is going to be your lesson for today. So hopefully it should be easier than yesterday since it's very similar material. Okay, my friends?